Welcome to the Jce Connect classes. Design, develop and implement a recursive subdivided tetrahedron to form 3D Sierpinski gasket. The number of recursive steps is to be specified by the user. In this experiment, we are trying to get the gasket. Now let's see what is this 3D gasket. A fractal which can constructed by a recursive procedure means at each step a triangle is divided into 4 new triangles. You can see in the image every triangle is been divided into 4 new triangles. Subdivide into 4 smaller triangles by bisecting the sides and then to remove the middle triangle from the further consideration. It means the central triangle is removed and each of the other 3 treated as the original was, and so on, creating an infinite regression in a finite space. So it will have a lot of triangles, it will be infinite steps. So you can see the last 5th image of this. Let's talk about the 3D gasket or tetrahedron. A tetrahedron is a polyhedron composed of 4 triangular faces, 3 of which meet at each vertex. The tetrahedron is the only convex polyhedron that has 4 faces. This tetrahedron is the only convex polyhedron which has 4 faces. You can see in this there are the 4 triangles. The middle one was removed, so it is a white color, other are blue in color. In the second part, the triangle, again there is a pink color, a fade one, so that is also now number of divisions. If I consider the number of divisions to 0, so here you can see I'm considering the number of divisions. So when the number of divisions are 0, we can see there is no division of the faces in this case. So there is no division at any face. There are the 3 faces which are visible, so there is no division at all. When I make say number of division to 1, you can see the faces are being divided now. Okay, these are divided. It looks like there are the multiple faces now. These 3 faces are being divided. If I make number of division to 3, now this is a 3-dimensional gasket. So you can see minutely the number of triangles which are divided, and the central part of that is getting removed, and this is how it looks. In the further portion we'll be seeing how to implement this, as we are supposed to make a program for this. So let's go ahead with the programming concept of this. Let's begin with the implementation, how it is going to work. So here you can see the program in the fashion of we are using studio.h, mat.h and glut.h file. Now what I'm going to do here, you have to understand, here I'm using a tetrahedron which has 4 variable vertices, and we are mentioning its values at xyz axis, Okay, so this is how now the implementation, this further portion right from the main. So I'm asking enter the number of divisions, and it is holding by the n variable. We are initializing the glut by passing the argument c and argument v, and we are making glut initialize display mode, which has a glut single, glut RGB and glut depth. We are giving all the 3 modes for displaying. Okay, it is single, it has a RGB color and it has a depth. We are mentioning the window size also as a 500 by 500. We are giving the window position to 00, and we are creating the window by giving the name 3D gasket. Here glut display function is calling the user defined display function, and we are enabling the depth buffer. So here GL color we are going to give. GL ortho will be seeing about display function. So in the display, GL matrix mode, GL projection, GL load identity, GL ortho, it specified the coordinates of the x, y max and z plane and power plane. These are the parameter value which has to be passed to the GL ortho. GL matrix mode, changing the mode to GL projection to the model view. GL clear the GL clear buffer bit, and GL underscore depth underscore buffer underscore bit. It initializes the depth buffer. It initializes the Z value. We call upon the tetrahedron function, and the parameter that we are going to pass is n, which are nothing but the division entered by the user. We will be using this tetrahedron function now. Now GL color. GL color, we target about the GL color, how it works. So here let's talk about the tetrahedron function. In this tetrahedron function, we have called int m. M is nothing but the size, the number of faces. So here GL color 3F, 3 faces. So here I'm initializing with the first phase, saying putting at first phase 1.0, second phase 0.0, third phase 0.0. It means we are enabling the first phase. So I'm calling a function divide triangle. Now the first phase, if you are able to see here, we are considering v of 0 vertices 1, vertices 2, and m. So 0, 1, and as I have numbered them 0, 1, 2, 3, the first phase can be visualized as 0, 1, 2. That is, so the vertices 0, 1, 2 will be enabled. Along with that, the number of divisions that we have considered. Same way, if I want to consider the second phase, which is a backside phase, it is not visible. So I'm calling a function divide triangle 3 vertices 3, 2, and 1. Okay, so it is not visible. That is a behind phase. I'll be calling that. In the third phase, if I call as a say 0.0, 0.0, and 1.0. So the vertices which will be enabled is vertices of 0, 3, and 1. Okay, and the last phase, which is the base phase. So here I'm considering it is a combination of first phase and second phase. So 1.0, 1.0, and 0.0. And here I'm going to call at vertices 0, vertices 2, vertices 3. So this is how we are going to make the concept very clear. So in this way we are able to get the triangle. Now let's talk about the void divide triangle. So here we have 3 floating point variables or the arguments, and along with one m variable. So those are 3 nothing but is 3 variables, 3 faces. Now what we are doing here, let's try to understand. Here we are considering the variables one that is my arrays v1, v2, v3, which are holding the 3 elements int I, and here I am considering if m is greater than 0. We have considered 4 parameters in a divide triangle function. M, that is division. If it is greater than 0, it has to execute this scope of the program. If maybe if it is not getting if it is not greater than 0, it is less or equal to 0. So there is no need of dividing anything. So we are able to simply draw triangle as it is what is being asked. No need, and at the end they are supposed to simply draw the triangle. no need of division at all, because we are not asking any division to do. Okay, now let's talk about if m is greater than 0. Okay, now we'll see how this works. So an important thing here is to compute the midpoint vertex. Okay, now here we are considered three different faces, say A, B, C. We have a three different faces. Now how to compute these things? Okay, you can see the variable the vertex 0, 1 and 3 are renamed as A, B and C, and I have considered the vertex V1, V2 and V3. How they have been calculated? These are the midpoints. Now how to compute this? This is very important. So I am using a first looping statement stating so for V1 is nothing but A plus B by 2. In the same fashion, say V3 is B plus C by 2, and this V2 is A plus C by 2. Yes or no? These are the midpoints. This is very simple to compute. Okay, now further part will be the divide triangle. We will be seeing how it works. So for I equals to 0, I less than 3, I plus plus. So V1 of I is nothing but A of I plus B of I by 2. And in this case, divide triangle, how we are going to do? Dividing the triangle, it once you midpoints, and it's very important to divide the bigger triangle into through three different parts. Now for the face 1, you can see that it is a part of A, V1 and V2, and this time it is already divided once, so the number of division will be now m minus 1. Number of divisions will be m minus 1. So we are passing, again we are calling the function, it is a recursive function, divide triangle, saying that, but this time A, B, C values are different, A, V1, V2 and m minus 1. In the same fashion, if it is the second thing, so it will be B, V3, V1 and m minus 1. If it is the last, it will be C, V2, V3, m minus 1. So these are the three different phases that we are seeing. Okay, now as we have seen for first phase, we have done the same thing for the second phase, third phase and fourth phase. It will repeat the procedure. It will completely repeat the procedure for each and every phase. The complete procedure is done for one phase now. For the second phase, it will repeat the procedure. What we have done, we have computed the midpoint, then we are calculating dividing. Once we get the midpoint, yes, the arguments for the divide triangle will be changing. It is possible only when m is greater than 0, because once we are dividing, the value of m is getting minus by 1. So when it less than 0 or equals to 0, it simply draw the triangle at the end. It will not do any other stuff. Okay, so this is how a function divide triangle works. Here in the GL begin the triangle function, we require three variables. So in the GL begin is able to calculate draw the GL polygon for the vertex A, GL vertex B and GL vertex 3. How it goes? It shows the solid plane. It shows the solid plane, and it gives you the complete polygon with the three vertex what we have adding. So this will work when the m value becomes 0 or less than that. So we are able to draw the triangle like this. In the in the display function, we are calling the tetrahedron function. It divides the triangle into multiple triangles, and the GL flush will remove everything and glut post redisplay. It helps to call the display function multiple times. this is how we are again displaying the required object. We have called the display function. Okay, so this is how we are able to display the things. To get the enable the GL path, we have to use the function GL enable, where it will check the GL depth test. It is checking the test status of this, if whether it is enabled or not. If it is getting enabled, then only it will work. So it is checking whether it is enabled or not. GL enable is very important to test it. It enables the depth buffer. The next is GL clear color. It checks the background color with some different value. Here we have given the white 1.0, 1.0, 1.0, 1.0, and it again call the glut main loop. So it again goes back and does the things, and this is how I'm returning the 0, which is nothing but end of the program. So I have entered the value is 3, and this is an output that I am getting over here, and this is what the output. Anyways, thank you.